Hello, IT expert. Welcome to my Straight to the Point course series. My name is David and I work as a system security engineer. My main jobs are analyzing and securing Windows infrastructures. During my career, I have analyzed over 30 different companies with various environments. I use the knowledge from my course every day. It is crucial for my job. I believe it can also help you with securing your infrastructures or with advancing your career. I would also like to mention that I have Windows Infrastructure Security course, which is my flagship course, so definitely make sure to check it out. I also post almost daily about technical topics, so for example about securing Windows infrastructures and Active Directories on my LinkedIn page. So please take a look at my LinkedIn page, Horizon Secured. You can also scan the QR code in the right corner that leads to my website. I also provide some free resources to students, so make sure to check out my academy, where you can find, for example, my Active Directory vulnerability scanner called AD Probe, or some security guides, learning path, or even some free courses. I also provide 0 days notification service for my customers. Thank you for choosing my courses. Enjoy the course. Hello, welcome to Windows Security System Protection chapter of Windows Infrastructure Security course. In this course, we will talk about some default protections that are available in Windows operating systems. But let's first discuss how computer actually boots. So let's discuss initialization process. When you start your computer, first thing that loads up is UEFI or BIOS. So nowadays, of course, you should be using UEFI because of some security features that are available there. Then operating system of Windows 10 loader loads up. Then kernel mode of operating system, system drivers of that operating system, some system files, early launch anti-malware drivers, third-party drivers, anti-malware, and Windows sign-in. Those are the phases, or let's say components, that actually take place in that specific process. During those phases, every of that component or every of those phases can be targeted by attacker. So for example, if we are talking about UEFI or BIOS, it can be attacked by some bootkit. About system drivers, they can be, for example, attacked by some rootkits, because if an attacker is successfully able to load up some system driver in that operating system, then of course attacker has control over the whole operating system, including your user's secrets. Speaking about third-party drivers, of course, attacker can just load some third-party driver into that operating system. This is of course a big issue because it can be anything that is not Microsoft, so it can be any kind of keyboard, mouse, graphic card and things like that. So something just really basic as let's say a Razer keyboard or Razer mouse that in the past, for example, had some vulnerabilities in them. So this is of course a big issue that we need to take into account. And then of course some typical malwares in Windows environment itself. So malware is attacking, for example, user space, user mode itself, when user, for example, downloads something malicious from the internet, or he clicks some phishing email. So in this chapter, we will talk about how to protect all of those phases and how to protect against attackers. First phase we will be talking about is UEFI. As I already said, we should be using UEFI nowadays because of some security features. One of them, for example, is Secure Boot. Secure Boot basically checks the signature of each piece of boot software. So that specifically means it checks the signature of firmware drivers, FP applications, and operating system loader. It's of course in place to say that it's not just checking the signature state, so it's the same as it was before, but it also checks if the signer of that specific binary or driver is actually trusted one, because in secure boot you have different components which are, for example, signature database, revoked signature databases, signatures database, and key enrollment database. So basically, if you trust that signer, you of course must have this signer in signature database. Then if you, for example, revoke some signature because you know that some specific authority or binary could be abused or compromised, then of course you must add this signer or some image hash into this revoked signatures database. One of the case you might recall actually is from 2024, I think, when there was a problem with devices using UEFI secure boot and they were not able to boot up anymore. It was because of some Microsoft update. It was in February, and it actually broke secure boot because there were actually some changes how secure boot interacts with those signatures from those databases. And because of because of those changes, then, for example, virtual machines from VMware were unable to load up because those signatures were invalid from the perspective of secure boot. So that was, for example, one case that happened last year. In the picture, you can see the settings of virtual machine from vSphere, so from VMware, and you can see that there is a firmware FI and secure boot is enabled. So that's all it takes to enable your secure boot. If you have hardware server, then you have to, of course, enable it in UEFI. If you have Hyper-V, then you enable it on the Hyper-V level. So it's really not hard to enable it, and you probably won't even know about it. So it's definitely something you should turn on, and you should definitely enable it. It's nothing, it actually breaks nothing from my experience. Another example that actually happened in 2022, maybe you might recall a Black Lotus exploit that actually was able to bypass secure boot, and it was because of that those attackers or that attacker group actually created a bootkit that consisted of copies of those legitimate but vulnerable binaries that were actually trusted by secure boot. Microsoft actually created an update for it, and this update basically prepared our computers, our Windows operating systems, to revoke those let's say signatures, those specific binaries. But it's not actually automatically enforced. So Windows operating systems right now, if they were installed with some previous images from Microsoft websites, then these binaries are still vulnerable, because this update that Microsoft created just prepared that specific computer, specific device, to actually manually revoke those signatures. It's definitely something to bear in mind, because Microsoft is going to fully enforce this in half of the year 2024. So it's definitely something to prepare for, because once this happened, once this is gonna happen, then of course something could stop working, for example, or your booting images for installation of Windows servers or Windows desktops will stop working. So definitely check this out. Try to Google it. And prepare for that change. Okay. Another security feature of system protection that is available in Windows operating system is something called Trusted Boot. As you can see, it protects all operating system loader, kernel, system drivers, system files, and also early launch anti-malware drivers, which we will be talking about them in a minute. Trusted Boot actually consists of two parts. One of them of two features. One of them is that operating system loader itself verifies digital signature of Windows kernel. It's not the same as with Secure Boot, because as I already said, Secure Boot of course checks that those signatures are correct and the same as they used to be, but it also checks that the signer is trusted. With Trusted Boot, it's not the case. With Trusted Boot, those checks are only about those signatures to be the same as they were with last successful boot. So there is nothing about trusted signers, etc., etc. This, of course, is checking for integrity, just as with Secure Boot. Just remember it. That's why it's bold here, because it's from CIA triad, where I stands for integrity. Then, after operating system loader verifies the digital signature of Windows kernel, Windows kernel verifies the rest. So Windows kernel verifies signatures of system drivers, system files, and early launch anti-malware drivers. As you can see in the pictures, there is not much to actually search for on the Microsoft websites. So this technology is a little bit foggy from my perspective, because it's really hard to find anything about it, especially about enforcing it. So this, what you can see in the screen, is actually all that you can find on Microsoft website. One more thing that you can find is that screen or that picture that you can see in the right side, where you can see that Trusted Boot is mentioned just below Secure Boot itself. You can even see that there is something called Measured Boot. That's something we'll be not talking about, but just a quick introduction. Measured Boot means that you have some trusted server in your network that is actually able to evaluate states of your devices that are using those secure boots, trusted boots, and technologies like that. So that's also something that you can use. So as I said, documentation is a little bit foggy, especially about enabling this feature and enforcing it. But I have found one post from Microsoft employee that says that it's actually from somebody called Derexu, and he explains what is Secure Boot, and he also explains when Trusted Boot is enabled. So if Secure Boot is enabled, then Trusted Boot is automatically enabled as well, where it works in conjunction with Secure Boot to help prevent malware and corrupted components from loading. So basically, if you enable Secure Boot, Trusted Boot should be enabled too. There is no policy for it or no registry for it, or not, at least as far as I know. So you must trust this post, basically. Early launch anti-malware. Early launch anti-malware protects the face third-party drivers, because it's basically this function basically examines every third-party driver, and basically it determines whether it is on the list of trusted drivers. So if you have, for example, any kind of third-party driver, so even that mouse, keyboard, anything like that, then this early launch anti-malware feature basically examines that driver and determines if it's enabled or if it's able to load into the operating system. It can be different for every anti-malware or antivirus solution. So basically, if you have Windows Defender, which is by default presented in Windows operating system, then you have group policy where you can actually say which kind of drivers you want to be able to load up in that operating system. So you have 4 levels here and 3 different types. So we have good, which are signed and not tampered with. So the early launch anti-malware feature knows that it's the same as it was in during last successful boot, and it knows it's signed. Then there are bad drivers, which are basically recognized as malware by that anti-malware solutions. And then we have unknown, so it's not trusted, it's not, let's say, signed, but it was also not recognized as a malware. So what usually you can find in security baselines, you should definitely go for good only, which means that you want signed ones, so trusted ones, and definitely not tampered with. As I already said, there are different antivirus solutions that are using this. So for example, McAfee, Symantec, but the specific implementations can actually vary. So that's something to bear in mind. For example, Windows Defender has this kind of list of trusted drivers in registry. I don't know what about McAfee and Symantec, but they can be using it, of course, differently or in the same way. Anti-malware protects our Windows sign-in phase, which means the phase where we basically log in and where we work, where we do our daily tasks. So in Windows, we have Windows Defender. It's by default for free. It's pre-installed, and it pre-installs from Windows 10 and from Windows Server 2016. So you don't have to pay for it, and you do not have to install it. You can configure this anti-malware solution through group policy objects, basically as with everything with Microsoft technologies. And it can be updated through Windows Server Update Services, which is of course convenient because you do not need any kind of opened ports to the internet from those end devices and from those Windows servers. So you just need to get Windows updates from your Windows Server Update services provider. So as I already said, it's for free, but of course there is some pitfall, and that's it actually does not come with some central management. You can edit later on with, for example, Microsoft Endpoint Configuration Manager, before known as SCCM, but it of course costs something because you need license to actually implement this kind of solution. It also does not make sense to implement it just for Windows Defender management because as you might recall, SCCM is for deploying endpoint devices, for deploying applications, for updating devices, for creating some reports, etc., etc. So this is not its main focus to be managing Windows Defender. But if you already have it, or if you have some licenses, as for example, Enterprise Management Suite license, then of course, why not to use it for this kind of management? One benefit that is definitely there is that Windows Defender can be integrated with Microsoft Defender for Endpoint. So that's actually EDR from Microsoft that we can use with this default Windows Defender anti-malware solution. In the picture, you can see Magic Quadrant from Gartner for endpoint protection platforms, and you can see Microsoft is actually doing pretty well. So it's just below CrowdStrike. So there is no reason not to trust Windows Defender specifically just because it's, let's say, for free and that you did not have to install it. It's pretty robust and pretty good antivirus and anti-malware solutions, and even that EDR, of course, is one of the best. So who else can see, better into that operating system than Microsoft itself? So with those kind of protections, we were actually able to protect all of those phases and components we have seen before. So UEFI and part of OS loader, operating system loader, we were able to secure with secure boot that actually checks if signatures are in the same state, and that they were not modified, and that the signers are trusted. Then we have Trusted Boot feature, which secures operating system loader, kernel, system drivers, system files, and early launch anti-malware by checking those signatures that they were not modified before. But it does not check for trusted signers. So that's not the case. That's with Secure Boot. Then we were able to secure third-party drivers with early launch anti-malware feature, which, as I said, can be implemented differently with different antivirus solutions. So with, for example, Windows Defender, we can configure it with group policy objects and we can just enforce it. And then we were able to actually protect ourselves against malwares. So specifically in anti-malware and Windows sign-in phases or components. So we can here, for example, of course, use Windows Defender or any other solution, CrowdStrike, Trend Micro, Asset, and solutions like that. So we were able to protect ourselves from those bootkits, from those rootkits, from malicious drivers, and from malwares. Of course, you may you might say that there are different kind of security solutions and features that can protect us, for example, for malwares, and you are definitely true, because the most of the threats that are actually they that are coming nowadays are actually malwares that are targeting specifically users and their mistakes. Specifically talking about some phishing attempts, some social engineerings, same passwords, short passwords. They can download some malicious drivers or applications from the internet. So that's where the attack surface is actually huge in this user mode area, in this Windows sign-in phase specifically. So we need ourselves to protect against malwares a little bit more, because anti-malware solutions, of course, can be bypassed. What can we use, for example? We can use application allow listing. Application allow listings helps us to actually configure which applications are allowed to run in our environment and which are not allowed to run. It's not just about applications, of course, it's also about different libraries, different drivers, different scripts, etc. etc. You should definitely use application allow listing in the allow method, in the allow mode, when we want to allow some known legitimate applications. If they are in-house or downloaded, it does not matter, but we do not want to block with this kind of solutions, because for blocking there is antivirus, anti-malware solutions, and blocking feature is easily to be bypassed, because basically all you usually need is just to change one little byte, and then the binary or the driver looks completely different for this blocking feature. Of course, there is some behavioral analysis and things like that in EDRs and antivirus solutions, but that's something we will be not talking about right now. So definitely use allow mode with application allow listing. It's not a simple task to successfully implement application allow listing, because when you think about it, for example, you have some enterprise that has thousands of end devices and hundreds of some servers, for example. Just think about how many applications they are probably using in that moment, from the user's perspective and from the server's perspective. So you have tens or maybe hundreds of applications that are probably developed in-house, or that were developed in the past, and there is no support for them, or no developer for them, for example. And all of those applications you must take into account and create some rule set allowing them. So that's of course a really difficult task to do. So that's why you should definitely bear in mind that those kind of projects take years to finish. It's not an easy task, and it of course takes a lot of even from customer side, because they need to provide a lot of information. They need to audit that environment before they actually enforce some rules. So it's kind of difficult. From the Microsoft perspective, we have AppLocker and Windows Defender application control available. So AppLocker, it's the simpler one, I would say, for application allow listing. It's more convenient. Windows Defender, on the other hand, Windows Defender application control is, for example, AppLocker on steroids. It's a little bit more difficult, but it's definitely something that can enforce stronger policies, because it can even access kernel mode and can be checking kernel mode drivers, for example. So it's definitely something to bear in mind. Then there is Smart App Control, which is kind of a new thing. It's available on Windows 11 22H2 fresh installs. It's based on Windows Defender application control, but it's not still enterprise ready. I think it's from Microsoft is some kind of new application allow listing that should be as strong as Windows Defender application control, but should be as simple to implement as AppLocker, for example. But let's see, it's still not enterprise ready. There is actually no granular configuration how to let's say allow one application. And there is a ridiculous requirement that you must send optional data to Microsoft to be able to enable this smart app control, which is kind of ridiculous, because this is one of the first things we configure in our security baselines, not to be sending any kind of information to Microsoft, of course. So let's take a look, for example, in that AppLocker feature. So AppLocker, as I said, is for allow listing or block listing, but of course use it in allow listing mode. It can allow list executable files, scripts, Windows installer files, DLL files, and package apps and package app installers. Those package apps and package app installers, this is actually that bloatware we were talking about in the chapter about Enterprise LTSC version of Windows 10. That is actually missing those kind of this kind of bloatware. AppLocker has one huge pitfall, and that is actually AppLocker runs in user mode space. So it runs basically as, or not specifically in user mode space, but it actually runs as a service in that operating systems, which means that if you are an administrator on that computer, you can just turn off this feature. So that's a little bit inconvenient because you must first get rid of administrators' privileges for users, which is anyway something you should be doing before application allow listing, because if we would be speaking about some maturity level in cybersecurity, then definitely one of the first things you must do is remove administrators' privileges from users, and then of course rotate passwords for local administrator accounts. But anyway, it's of course it's worth a mention that that service can be stopped by administrators. So if there is some privilege escalation path or some, let's say, vulnerability in that service or in that application, then it's really easy to bypass this specific application allow listing. You can configure it through local group policy editor or through group policy management console in Active Directory. It's really easy to navigate through, so it's kind of simple. You can even see, as you can see in the picture, you can even create some default rules. Do not expect anything from those default rules. They are definitely not secure. Like, it's not something you want to configure and just let's say you are finished with that project. No, it does not work that way. Those default rules are definitely they have many holes in them. For example, one of them is that Microsoft Teams is installed, that software is installed in app data of that specific user. And for example, as you can see in those rules, there is no allow rule to access those app data folder, that app data folder. So that's, for example, one thing that will stop working, and that's just one example. Then there is, for example, second case where everyone is allowed to run everything from Windows folder with those default rules. But in Windows folder, there is a Windows 10 folder. And in Windows 10 folder, the ACL, access control list, actually allow users to drop any kind of executable file they want. So they would be able to run anything they want, basically. So those default rules are not something you want to be using. So definitely find something else or develop some of your own. One benefit is that you can audit or enforce this application allow listing, which means that basically when you create some set of rules, then you can just turn it in audit mode, which means that in event log you will see if that application or script would be allowed to run or if it would be not allowed to run. This is something I highly recommend because you can break with application allow listing your computer. It will not even be able to boot up. So definitely test it with this audit only mode, and the planning phase should be really, really lengthy actually. It's only user mode oriented. So that's, of course, as I already said, that relates to that specific service that actually is running there. And those rules are defined per user or per group. So basically you specify some user or some group, and you can granularly say, for example, that administrator or somebody is able to run this and somebody else is able to run this application. So This can be of course convenient. Uh, in the slide you can see that there is a URL to github.com Microsoft Aaron Locker or Aaron Locker. This is a place where you can find some PowerShell scripts and some documentations that will make your life with implementing AppLocker much easier. I highly recommend it. It will help you to successfully implement AppLocker, and it will help you to protect your environment correctly. And basically, as I was talking about those security holes in those default rules, so those scripts are also something that are actually searching for. So they are searching for those kind of misconfigurations or holes in those rule sets, and they will help you to make it better and make it secured. So let's take a look into our demo and let's play a little bit with AppLocker. Let's take a look into our demo environment and let's demonstrate how to use AppLocker and how to create some basic rules. And also we will demonstrate how to use Aaron Locker project that focuses on creating AppLocker rules in a little bit more complex way. So we will be creating those AppLocker rules through our domain, so through Group Policy Management Console. So we want to enforce it that way. And we'll be creating those rules for our device ADCLNT02. We have seen this device before in other demos. Right now we are on our server where we have this RSAT console available. So we are on AD server 01. And I am of course domain administrator, so I'm able to create that policy. I will be creating a policy based on some binaries. So I have here, for example, sysinternal suite from Microsoft. Those are binaries signed by Microsoft specifically, as you can see here in digital signature in properties. And this is what I'm going to use for that AppLocker rule. So the goal will be that I am not able to run process hacker because process hacker binary is of course signed by somebody by somebody else. So this is the goal over here. So let's create that policy. So let's name it, for example, AppLocker policy. And let's get into it. Okay, edit, policies, Windows settings, security settings. And now we are looking for application control policies, and then we are looking for AppLocker. Be careful, do not use software restoration policies. Those are old policies, and nowadays we use, of course, AppLocker. So always use application control policies. As you can see, we have here a list of some rules. So executable rules, Windows installer rules, script rules, and packaged up rules. If you remember from my presentation, then we are missing here DLL rules because AppLocker can also create rules for libraries. To be able to see libraries, we need to go Properties, Advanced, and enable DLL rule collection. As you can see, here is a warning because Microsoft knows that it's very easy to break your computer with those rules. So that's why they are hidden. That's why they are actually not listed by default, because Microsoft want to kind of warn us. So we bear that in mind. Okay, and if we click OK, we can see that script rules are here. But we want to focus only on executable rules right now. So let's create some really simple rule. So we have here some wizard. It's really simple. We select if you want to allow or deny. So we will set, of course, allow for everyone, because as we have discussed during my presentation, we want to use application allow listing for allowing applications that we trust. So everything else gets blocked and denied if it's unknown, because for denying we have antivirus and anti-malware solutions that are of course using different approach, and then they are denying the things that are bad and that are known. So that's why application allow listing has different approach, and we want to allow only things that we trust in. So that's why we will set allow here. We will set condition based on publisher. And here we need to pick some reference file. As that reference file, I will pick that AD Explorer from sysinternal suite. And here you have some attributes that you can use, some values. And you have here some slider and you can slide this slider where you want, or based on that what you want to use. So I want to use just publisher, so I would slide it to this level. You can even custom those values, but that's not something I would like to do right now. So let's use just a publisher. That's the most easiest way right now. So everything from Microsoft will be allowed to run for everyone. Now we can add some exceptions. That's something you are going to see a lot if you are creating some more complex policies. But right now, let's just skip this part. And next, and let's create that rule. Right now, it's asking me if I want to create default rules, which I do not want to create right now. So let's click no. And we have just one rule over here. For that rule to be effective, we need to click properties on AppLocker, and we need to configure those executable rules, and we want to audit them. As I said during my presentation, you always want to start with audit unless you are very sure about what you are doing, but you always want to create those rules and set it to audit because you want to observe your environment, you want to collect some data, and you want to see what those rules are actually blocking in your production environment before you actually enforce them. Because there always can be some misconfiguration or something that you missed during that configuration. So let's do it this way. Okay, AppLocker is configured. Another thing you must do is that you need to enable application identity service, because AppLocker is enforced and those rules are enforced by application identity service. If this service is not running, then those rules are not effective. As you can see, that service is not running by default and it's set to manual trigger start. We need to set this to automatic. It's something that we are not able to do through graphical user interface because that service is protected. So even administrator is not able to turn off this service very easily. So of course, administrator always can find a way to bypass this service, but it's not that simple as it used to be. So we need to configure this service through our group policy management console, so through domain. So we will go to security settings, system services, and here we will find application identity service and set it to automatic. And that's basically all we need to do. So our policy is created and our policy is applied to our computer that is in computer's organizational unit. So let's switch to our computer. Let's just take a look if it's the correct one. Yeah, it's a correct computer. Let's just make it a little bit more zoomed because right now it's not the best. Okay, that's better. And let's just try to do GP update force. Right now we are logged as a common user, unprivileged. So if I want to run, for example, PowerShell as administrator, I am not able to do that. This shortcut that I do a lot, which is Windows X. So you can just do Windows X and A, and that opens PowerShell as administrator. So if you are interested in those shortcuts, now you know how to use them. So let's just take a look if those rules are actually being applied. Right now we are in audit mode. So let's just open Process Hacker and let's open something else, just command prompt or something. And let's also take a look into those services. It's already configured to automatic, and if it's running, because if not, yeah, it's running. So right now, AppLocker should be effective. How do we know it? So we, of course, will take a look into our event viewer because it's in audit mode. So it logs, of course, what it does in the background. So let's go to applications and services log. And there we will find our AppLocker container where we will see some logs that are actually saying if the application would be prevented from running or not. So Microsoft, Windows, AppLocker, and we can see that there is nothing right now. So let's maybe relog first. And then it will be probably effective already. So let's just sign out and sign right back in. And let's see if something is actually happening. Okay. And let's just go to event viewer and let's just try to find out again if anything changes. Okay, I will just open a few applications because I want to see if there is anything that would be prevented from running. So our example of binary that we want that we do not want to be able to run is Protezhacker. So that's why I am always opening that. And let's go to Windows and let's go to AppLocker. Okay. And we can see there is one event, so that's actually not much. And we can see it was applied successfully and the time is actually correct. But I wonder why it actually does not do anything. So let's just try run something else. Now it actually works. So it just took a little bit. Okay, so now we can, for example, close that AppLocker again and open it because it probably just took a little of time for that service to run before it actually knew it's configured. So let's just skip this. Oh my god, it's so annoying. Let's close it. No, we cannot even close it. Okay, so thank you, Microsoft, for those steps. And let's open Protezhacker again. And let's just take a look if it does something. And as you can see, we are getting a warning here that Protezhacker was allowed to run, but would have been prevented from running if AppLocker policy were enforced. If we want to run anything else, you can see that MSH was allowed to run. What else do we, for example, have here? Some setup, some task host. So everything else was allowed to run. So even if you would run, for example, PowerShell, it's of course signed binary. So we know that it will also be able to run. So we can see some con host and some PowerShell was able to run also. So as we can see, it's probably we can enforce this rule because we can see that just Protezhacker was blocked or would be blocked. So we know that we will not break our computer with this rule and that we will be actually able to log in because I think it can. If you configure AppLocker really, if you misconfigure AppLocker, that's the better word, then you can have some problems with your computer because you can deny some libraries or some applications that are necessary from that operating system. So for that operating system. So let's just try to enforce those rules. So I will not sign out. Let's just first configure it. So let's go to AppLocker and let's go to enforce mode. Okay. So we are enforcing those rules right now. Let's go back here and let's do GT update force and let's relog because as we tested, we could see that you must relog actually before you configure your AppLocker policies. Or at least this is how it behaves for me right now. So let's just log off and let's log right back in. And let's see if our application policies are actually working. Okay, and we can see that Protezhacker is not able to run and it has been blocked by your system administrator. But as we can see, CMD, for example, is able to run, or if we go to that sysinternal suite, because I have it also here, tools, sysinternal suite, we can see that ID Explorer is also, or let's just give it a while because now it's gonna be scanned by Smart Screen also. But I do not have internet connection, so it takes a while. It needs to time out because the Smart Screen will be not able to verify this. So let's just give it a second, or I can try something else probably. But let's just see what else we can for Process Explorer, for example. It's also triggering Smart Screen. But if we give it a while, we will see that we will actually be able to start those applications because those binaries are signed by Microsoft, and that's what we actually used in that AppLocker rule. So that's what we used as a signature. Okay, so let's just give it a second over here so we can see it actually works. So I am back. I really needed to stop a Smart Screen or to disable Smart Screen because without internet connection, it was actually preventing AD Explorer from running. So right now it's still configured the same. So still I am not able to run Protezhacker because it's not signed by Microsoft. And if we try to run, for example, AD Explorer, we can see we can run this application because of course this application is signed by Microsoft, just as well as others. So if I want to run, for example, Process Explorer, I am able to run it right now because Smart Screen is turned off. so it's not blocking us no more. And AppLocker is allowing this application to actually run, as you can see. Okay, so this was the demonstration of really basic rule creation. And now just take a look into our Aaron Locker project, or not our, but into Aaron Locker project and into our demonstration. So what this project is really about. So you can basically go to GitHub Aaron Locker, and if I just refresh it, so you can see it. It's a project from a guy who actually created PowerShell scripts to help you to create AppLocker rules that are a little bit more complex, because as I have also mentioned during my presentation, there are many bypasses for AppLocker default rules, because users are able to run a lot of binaries from different locations in operating system. So those PowerShell scripts should help you with creating some more complex policies. So if you download this project, you will get AppLocker mine. So I will just extract it to this location. We'll play with it just for a few minutes. So you need to, of course, you should read the documentation, read the manual, and play with it a lot. But we will just try some basic, let's say, creation of those rules itself. You have, as I mentioned before, it's just PowerShell script. So that's all you can see here right now. So first thing you need to do, you need to be able to run PowerShell scripts. So I will just set execution policy to bypass. That's not something you should be doing in production environment, but for the demonstration is the easiest for me right now. I'll just make it a little bit bigger. Okay. And now we need to actually run, okay, we need to install, access checker, because Aaron Locker actually, okay, so that's weird. Aaron Locker or those scripts are using access check tool that is actually from sysinternalized suite. We have seen it before. We have seen it over here. Okay, so this is this utility, and it helps those scripts to scan for different directories, different ACLs, different binaries, etc., etc. So that's what we need to do right now. Okay, so what was the name of that script? It was download. Okay, download access check. So let's just download this utility. It's gonna take a while, because in this production environment my network is really slow. So let's just give it a moment, and then we will run few scripts to see what it actually does. As you can see, you can use it even for Windows Defender application control, but that's not what we are going to use right now. In this demonstration, we will be talking purely about AppLocker. Okay, and here we have it. So right now we need to run create policies in the Aaron Locker folder. And this script will actually scan our operating system and our directories for some safe locations and unsafe locations, because that's how it actually separates those two from each other, because it knows what it's supposed to be in that operating system and what is not supposed to be there. So as we will see in a while, is going to create some scan results where we can actually find those results. As you can see, it's searching for some default locations. It's looking for OneDrive and for all those things. So it's really complex. So it should really help you to create some really good application allow listing policies. Okay, so we can see it actually scanned our computer, and we can see here are some results. So what we can find here are some XML files and text documents, and we can see what writable directories are presented in that operating system for user. So in Windows directory, we can see that are few directories that are actually writable from user perspective. So those are directories that need to be actually or we need to create a rules for those directories, so we are not able to run applications from them, of course, because if we do not take those directories into account, then user could just, of course, put a binary in there and just run that application. So that's why we have them here. You can see that in few places there are even alternate data seen, because here you have just a folder and asterisk, and here you can see it's about alternate data. Okay, also you can see here program files 86. So there is also one path that is writable from user perspective. It's in Microsoft Edge. And in program files there is nothing by default. So this is just some default scan. Nothing is created so far. If we have some some custom directories that we want user to be able to run applications from, we need to, of course, take them into account, and we can even scan for them. So if we know about it, we can, for example, create scan directories PowerShell script, which is here. And we can just, we can, of course, do it for Windows directory as we tried before. So we can see that we do not need any directory over there. If we do the same, for example, for program files, it's right now just that one which we have seen in the text file, so it's still the same. But we also want to scan for our, okay, let's just, for example, try program data, because in program data there is a lot. And what does this script actually do? It actually scans for binaries that are in those directories. So we need to use those directories, of course. So we can see that, for example, in program data, there is a lot of, okay, let's just use it with grid out view because it will be better. And we can see that, for example, in program data, there are a lot of binaries and applications that we need to use. As we are going to see, it even says it's a safe dir, so it knows it's okay, it's supposed to be there, and we can see that for those kind of applications, we will need to create some rules so we are able to actually run them, because we would block Defender from running. That's not what we want to do. Okay, so this is what this script does. It shows us how the rules are going to be created. But those are safe directories, so they are by default taken into account by those PowerShell scripts. But we can also scan for custom directories, because as we know, we have here some tool directory in, okay, non-default root dirs. And we can see it found it. So in C there is tools, and now it's looking for some binaries there. And let's again use grid view. You could also use Excel. So if it's better for you, you can use it. I do not have Excel here, so I am using grid view. And if I run grid view, I will find that I have many applications that are in this unsafe directory tools. Unsafe because it's not default, so it's not something that those scripts would allow to run, because before with Windows Defender it was safe there, so it would be allowed to run if the rules are created. This is something that would be not taken into account by those scripts because it's unsafe directory. But we know that we like this kind of directory, and we want to be able to run those kind of applications from those directories. So we will actually use this. Okay. How to actually say to those PowerShell scripts that we want to create uplocker rules that take into account our unsafe directory. So we have here those support PowerShell scripts. No, that's not here. Okay, let's just customization inputs. Yeah, that's what I am looking for. And here we have many different scripts, but let's just take a look into some interesting ones, at least for us right now. And that's this and also this, I think. Okay, and maybe take a look into trusted signers also. Oh no, that's VDAC. That's no. Okay, yeah, this is it. Okay. As I said, it's just PowerShell script, so it's better to read manual because it's not that simple as before when we were actually trying to create just one basic rule, right? So now it's a little bit more complex actually. So here, for example, in get safe pass to allow, we can see that the script is also looking for sysvol. So if the device is domain joined, then it of course will allow a user to run applications from sysvol because that's how it works. You want the user to be able to run those applications. And also you can see that here is that Windows Defender folder from program data, which actually we have seen before, right? When we were doing that search, that scan directory. Let's go over here. Yeah, it's it. When we were doing scan directories, search program data, that's where we actually have seen that specific folder. So it's already here. So that would be already taken into account. But as you can see, here is nowhere our C tools folder, of course. If you would, for example, want to use some trusted signers, we can add here some signers to use. So if you want to use, for example, a signer of that process hacker, as we have seen before, we would need to add this signer to this list. Okay, so we could use even that, but that's not what we are using right now. We will be using those folders. Here are also some default signers presented from Microsoft, and that's for some redistributables itself. So that's not what we are using right now. What we are interested in, is unsafe paths to build rules for, because as we have seen before, when we scanned those directories, we have seen that there was unsafe there, which was our C tools directory, which we need to create a rule for to be able to run those applications. So here we have some let's say manual, some comments, sorry. And we can see that, for example, one exception already that is here, that's unsafe by default, is OneDrive. Because OneDrive is located in local app data, so it's already here. Yeah, so similar could, for example, go for Microsoft Teams. So if we want to create some exception or some rule for our unsafe directory, so our tools, our applications, we can just create it in the same way. So I will just copy it, it will be faster. We will name it our way, so it will be, for example, custom apps, for example. And we will just create a path, so it's C tools. And that's for example everything. We will just create here maybe, yeah, let's just maybe leave it like this. Okay, and this is how it should actually work. So if we create this script, those scripts will actually create for us some rules that those will bear in mind our applications, and we will be able to run them later on. Let's just minimize it. Right now, if I run that script create policies again, it knows it already scanned our system, and it will just create those GPOs, those policies, based on those collected data. So it will be much faster right now, and it will just create some policies. If you want to run that scan again, you just can enforce rescan, or you can just delete that folder and do it again. That's also, of course, possible. But right now we are creating those policies, and as you can see, it's going through those applications in C tools, and it's creating policies for that. Let's just give it a while, and let's just take a look what it actually did. So it took a while, but in the end it created those policies. So we can see we have some output in Aaron Locker output folder. So let's take a look into there. So let's go to downloads, AppLocker, Aaron Locker, Aaron Locker, and outputs. So here we can see some policies or some XML files that were actually created, and those are our rules. So you can see that here is something from something newer. Those are our newer rules, and those rules actually take into account our C tools folder, because this is the first run, the first create policies run, which created those policies, but it was without our unsafe directory, so without those C tools, without SUSE internal suite, without process hacker, etc., etc. And those are the newer rules that we actually created after we adjust those rules, so it takes into account our C tools directory. So we can use now those XML files for our UpLocker. So I have created here, in the meantime, when it was creating those policies in those XML files, I have created a UpLocker audit policy, which we will actually use for auditing those rules, because as I said before, we want to audit first. Okay, so let's go to policies, Windows settings. Let's go to application control policies. And let's just go to UpLocker, and let's just do import policy. With this import policy, we want to go again to the same location, so to outputs, and we want to find the newest, the newer one, of course, which is over here, and UpLocker rules audit. You can see that it even creates rules for Windows Defender application control, but that's not the goal right now. You will see it in another demo. So let's just import this audit policy configuration. Okay, and we can see that some rules were actually added. And we can see that there are many different rules. We can see there are by some deny rules, some allow rules. We can see that it's even named after those custom apps, because that's what we actually added to those rules. And there are some other rules that do a lot actually. So we can see it's really complex right now. So this is why we are actually using it, because that's something that will help us to create some reasonable UpLocker rules. And if we apply this to some computer, we should basically see no difference right now, because everything that is there right now should be able to run. Okay, so let's just test it. Let's link it to the same computer. And let's just also configure that service again, because I deleted the older policy where we did that. So let's just do that again. And let's just configure application identity policy to automatic. Okay. And let's go to our computer, which is of course signed out already. And let's just try it again. Okay. So let's just do GP update force. Then let's just relog, so we know it's really effective actually. And let's just try to run a few binaries, and then maybe we will even try to find some binary that will not be allowed to run. So let's just first try to sign in again, just to be sure. It's probably not necessary, but it was like that before, so I just want it to work immediately. Okay, let's log in. And let's see what it does. So we will run Process Hacker, we will run Microsoft Edge. Let's run, for example, command line, and let's take a look into Event Viewer, because we know it's in audit mode. So now it actually does not do anything. Okay, so that's what it actually does right now. Okay, so let's just go to Event Viewer. Oh, typo. Okay, and let's just take a look into that UpLocker container so we can see what it actually does. In the meantime, I will just download, for example, Chrome, because I think that won't be allowed probably. Or let's see, maybe it will. Let's just see what it does. And let's go to Applications and Services logs. Okay, let's give it a while. I will just maybe try also something like FileZilla, because that's also something that's signed by a different publisher and different than we actually mentioned before. And let's see, Microsoft Windows, and let's go to UpLocker. Uplocker, where is it? Okay, it's here. And let's take a look, because now you can see it's getting filled, because now we have more rules than just one rule for a publisher, and we can see it does something. So we can see many DLLs are able to run. We can even filter it, so we can see just those that won't be able to run, but there is nothing so far. Okay, so that's actually good to know, because so far there is nothing that would not be able to run. So that's always good for us, of course. Yeah, before we can see that here was some errors, but that's something older. Okay, so far so good. So let's just download something else, and let's see what is going to happen to those binaries. As I said, it's a little bit slower. I am sorry for that, but let's just give it a while. Or maybe I have something, for example, in downloads folder. Oh, I don't. Okay. Yeah, but we are getting there slowly but surely. Okay, and let's just download this. Okay, something basic. Let's do the same for the Chrome. So we have 2 reference files. And let's just wait till it downloads. Okay, and here we are. Okay, come on. It's really slow today, actually, so I'm sorry for that. And FileZilla is almost done, almost. Okay, Chrome does not actually want to download itself, which is weird, so let's just help it a little bit. Okay, and let's just see what it changes for us if it actually applied correctly. Okay, so let's just try to run that Chrome setup, because right now, of course, I guess now it's again checking again some smart screen or something, so that's why it takes so long. And let's just run this, and let's just also run this. And I just want to take a look. Okay, so we need to provide administrator. Why not? It does not matter, because those rules are created for everybody right now. And let's just take a look here, and we can see it would be active. So we can see FileZilla would be blocked. We can see Chrome would be blocked. We can see basically both of those applications would be blocked. So let's just end those, and let's just switch that mode to enforce mode, so we can see it really it's really effective, right? So you can see it more clearly. Okay, so let's go to Uplocker. My bad. To Uplocker, and let's just try to configure everything into enforce, so that will be much better right now. Okay, and that's it. I could even, of course, take that enforce mode XML file and import it, but it's just really reconfiguring of those 5 buttons, and it's enforcing them. So that's why I did it that way, actually. Let's just do GPRA force, and I think we do not even need to relog, and I think we can just, okay, let's just do this, and now it's done. And so let's, yeah, okay, and you can see this would be blocked, and Chrome setup, of course, would be also blocked. So you can see it was not that complex, actually, but if we take a look into those rules, you can see it quite complex, because those scripts actually did a lot for us right now, right? So I highly recommend you to take a look into that project, Aaron Locker. So I definitely recommend it. It's a really clever guy, and I think this is amazing, and it can definitely help you to create some more reasonable and more unified and secure policy rules for your environment, because you can you could even see during the demonstration that we even added some directories, some tools that we wanted to be able to run, so you can even adjust those scripts so they take into account some other publishers, some other paths, etc., etc. So you can of course customize it, so you can always have uplooker rules based on your environment. So take a look into this, please, and of course take a look into his YouTube channel, where he actually shows some quick start. So that's basically what I did. So I just copied this quick start video and I did it myself, so you can see it. So definitely take a look into it and learn how to use it. And that's all for this application allow listing demo for uplooker. So let's switch back to our presentation. Windows Defender Application Control. As I already said, this is application allow listing on steroids, as I would say. But it's of course, let's say, difficulty. It's difficult to actually implement this. So it's advanced allow listing and block listing. Again, usually you should be using allow listing mode. But there is one more thing that you can actually allow list or block list with Windows Defender Application Control, and those are driver files. Everything else is just the same as with uplooker. Why there are driver files? Because Windows Defender Application Control is able to access even kernel. So it's not something you can just turn off from the operating system. It's something that's highly buried in that operating system in the kernel mode. So that's why actually you can see that you can protect many phases, many components just with this one feature. Because this application allow listing is, let's say, not just about basic application control as you would imagine, but you can even enforce something as kernel mode code integrity. You can say which kernel drivers are able to run. You can basically really configure every of those components and phases. Nowadays you can configure it with Wizard or PowerShell, and you can then enforce it with group policy objects. As you can see in the picture, so the first picture is actually Windows Defender Application Control Policy Wizard. This was not there before. Now it's a little bit easier because you can use this, and you can see that there are some free default modes that you can be using when you are implementing this kind of application control. And you can, for example, set the default Windows mode, allow Microsoft mode, and signed and reputable mode. This is basically just some standard security baseline that you can use for Windows Defender Application Control. But after you create this kind of baseline with those default modes, you of course need to modify it and to tailor it to fit your environment and your enterprise, of course. What comes out of this policy wizard? So it's just a XML file which consists of those lines you can see in the bottom picture on the left side. So this is how it actually looks like. You can even create those kind of policies with PowerShell. So that was the only way before. But nowadays, of course, you can use this kind of policy wizard. And then you just take this file and kind of implement it into that group policy you can see, deploy Windows Defender Application Control Policy, and you just include that file in that code integrity policy file path. Sorry. We will be talking a little bit about Windows Defender Application Control later, when we will be talking about specifically virtualization-based security, which also affects this kind of application control feature. You can also audit or enforce with this kind of application control, so it's the same as with uplooker. And then we have, which is a huge benefit, we have user mode and kernel mode, and we can configure both. So that's a huge benefit against, for example, uplooker, where you were able to configure just user mode. Those rules are defined system-wide, so you cannot separate or granularly say, for example, that one user can run this and one user can run this. No, it's not like that. So how to actually use those application allow listing features? So usually you would use Windows Defender application control as your base security baseline. So let's say some really basic stuff so that you are allowed to run everything from Microsoft, everything from that and that and that. So really just some standard, not so tailored baseline. And then for specific applications, you will use AppLocker. So if you have some other in-house applications and you need to granularly say which user can run what, then you would use AppLocker on the top of Windows Defender application control. So that's how you would actually implement those kind of application allow listing if you want to work them together. And it's also something that's actually recommended from Microsoft. So let's take a look into our demo again, and let's demonstrate a Windows Defender application control feature. So let's take a look into our demo environment, and let's demonstrate how Windows Defender application control works. Today we will be using Windows Defender application control wizard because it's much easier to deploy policies this way. You can of course create your own policies from the scratch, but that's not something we will be actually doing right now. In this wizard, you can create really simple rules, simple policies. For example, restrict computer to use just Microsoft signed binaries and drivers. You can even add some exclusions to it. So this wizard is kind of evolving in time. So Microsoft is still pushing some updates to it and some upgrades. So there are always some news. So that's of course a good news for us. So it's something that's usable a lot, and you can always create some baseline policy and then build on top of it. So that's what we'll be actually doing today. If you want to know more about Windows Defender application control, then of course there is a huge amount of documentation from Microsoft, so we can always go through that because this demonstration will be just a few minutes, so we will not actually go much deeper. Let's take a look into that wizard. So it actually used to be a binary file, .exe file. It was really easy to install it anywhere. Nowadays, it's MSIX file. So when you basically click to download this wizard, you click somewhere here, and you can see it's MSIX packaged application, which is kind of a bummer because when you are using, for example, Windows 10 LTSC long-term servicing channel or Windows Server, then you are of course not able to run this kind of file by default. I already pre-downloaded it, and this is how it looks like. So that's something you are not able to start just on Windows Server and Windows 10 LTSC. So what I did was that on Windows Server you can just run this commandlet. You can download that specific file, and then you can just run add appx package, and it's going to work. So that's really easy, and you have Windows Defender application control wizard here. Right now we are on Windows Server 2022. If you want to use this on Windows 10 LTSC, and that's what we will be doing today, then it's a little bit harder because if you want to use this commandlet, then you have to switch or at least reconfigure developer mode, and you need to use developer features, and you need to switch it from Microsoft Store apps to sideload apps. When you do that, then only then you will be actually able to to run this commandlet. So without it, you will be probably getting some kind of error message. So when you run it with this configuration, then it's of course going to work. So let's take a look into that Windows Defender application control wizard. So when you install this package, you are getting Windows Defender application control wizard. It looks really similar what it was before, what it used to be, but now it's more, let's say, you can set it more granular. So you can create some basic policies, you can merge them, you can build one policy on the top of another. So it's you can kind of play with it a lot. So let's just do policy creator because that's what we actually want to do. Here we have some, here we have more policy types. Again, we will be playing just with single policy format, so we want to have one policy per device right now because we will be just testing how it actually behaves, how it works in this specific environment. Here you can see that you can use multi-policy format, so you can use more policies, as I said before. So you have one baseline policy, and then you can have some supplemental policies, and you can see that you can actually have up to 32 active policies on the device, which is kind of cool. That's why I actually told you that I would create some baseline policy with this wizard at least, and then you can of course create whatever you want. So we will do a single policy format, which is what we want to do right now. Click next, and then you have some very basic modes, you could say. So you have here default Windows mode, allow Microsoft mode, and signed and reputable mode. So on the right side we can see this is the least restrict mode, and on the left side that's the most restrict mode right now. We will go with the middle way actually, because we want to allow Microsoft mode, where everything that is from Microsoft is able to be started or loaded, and we also want to load anything that's Microsoft signed, so that's good for us. Now you just provide some policy name. You say where you actually want to store this. So let's just change it to some more convenient location. Let's just say demo policy and ms signed. We'll also create some exclusion, which is cool because you were not actually able to do that before with this wizard, at least so far as I remember. And here you have some advanced options, so you can turn on or off some specific settings. There are many options, so you can actually turn on hypervisor protected code integrity, which means that those policies for user mode or kernel mode can be protected with some integrity checks. We will be talking about it a little bit later. And you can do kind of a lot over here, right? But we will just actually, we will be actually checking this option here, boot audit on failure, because that means if there is some driver failure during startup, then you are still able to boot the device because it will be actually automatically placed in the audit mode, that specific policy. So that's convenient when you are creating those for the first time, let's say, so you do not break your computer. You of course want to always create audit mode policy first, because that's the check right here. So we will leave it on, and then it's the best to enforce it. But of course there is always this option, so the device should always boot actually. So this is for testing purposes, of course. So let's just leave it like this. Let's just go with next. Then we have some file rules over here, and you want to add customer rule, because those are some signatures from Microsoft, of course, and I want to also include my folder, which is over here, and I have here some tools, sysinternal suite, and also there is some third-party app, I think, somewhere down here. So let's just create rules for this specific folder. This is very cool because I'm not sure that this was actually possible before. Maybe it was, but I find this very convenient. So we can create it for user mode. This really depends on where that application is actually loaded. If it's in user mode or in kernel mode, you can always check both of that if you are not sure if that application actually runs there or there. Okay, so that's not a problem. So we can keep it like this. Rule type, so I would go with file hash actually, because some things are actually not signed. Or maybe we can go with publisher, and yeah, that is signed by software publisher. And I think there is also some backup. So let's just try it with publisher right now. And let's try it this way. Okay, I want to actually go like folder. I don't want to do it for file. Oh, excuse me. Okay, sorry. We want to do folder scan. That's what I think was not there before. So we want to do folder scan. We want to find that specific folder. So it's basically pretty similar to that Aaron Locker UpLocker tool where you scan those directories and then you create rules based on that. So this is kind of similar, but it's from Microsoft. So let's check our sys internalized suite folder. And now we can select publisher and file hash. That's why I was actually confused that I was not able to check both of them. Okay, and this is basically how we want to create this allow rule. Unable to proceed through exception for this rule create. Okay, we just want to do create. Okay, excuse me. Okay, and we can see it's right over here. And I also will go with merge with recommended user mode block rules and merge with recommended kernel block rules. I will show you those later because there is some default configuration from Microsoft that actually says what is bad, what should not be loaded. So there are some Mimikatz drivers and some known drivers and applications. We'll take a look into that a little bit later. So let's just create that policy. And I will just prepare the folder for it. And let's see how it actually looks like. It creates two files. One is that that we will actually need for our group policy management console, because you can of course enforce it through group policy management console. So there is a specific policy for that. And there are also two types of policies, and that is unsigned and signed. So the difference is that if you deploy unsigned policy, then administrator of that specific computer where you implemented that specific policy is able to bypass that policy, because he can just delete that policy, delete that group policy, or somehow block it. We will actually take a look into that later too. But that's the huge disadvantage, that the administrator can still bypass those rules. And that's when signed policies come handy, because when you sign that policies, and it's really the word signing, so you are really using some certificate for it, then you can prevent administrator from bypassing those rules, those policies, because when you sign it, then it's actually protected by kernel. It's actually there is a secure boot required, so it's somehow protected from trusted boot or secure boot. And when that policy gets tempered or changed or modified, whatever, deleted, then that operating system will be unable to boot. So that's what you want to do, of course, in your production environment. We will be using unsigned one, because I want to show you how to delete those. But that's just for you to actually know that there are two ways how to actually do that. Okay, so we are good to go, and we have here policies itself. That's XML file. Those are the rules that I was actually talking about during presentation, that you can create those manually or with PowerShell, for example. And now it's created with that wizard automatically. So you can even see here that we have here some specific hash files and signatures. And why is here Secure Secrets Dumper? Because that Secure Secrets Dumper tool is not from Microsoft, and it has no digital signature, I think. So that's why it actually used that backup method, and that was hash. So it calculated a hash, and we should be able later on to use this application even though it's not from Microsoft. And then of course you can see here some deny rules, even though we did not create those, right? And those are actually the rules from Microsoft, that those two checkboxes where it was something like recommended Microsoft kernel rules and things like that. So this is the set. Those are the policies. So we can see though there are some hashes, some known bad PowerShells or malicious PowerShells, and it's a huge list, I must say. So it's really great that Microsoft is working on this, and I really like this solution. And I think we can even find here something that is more known to us. So for example, let's say some mimikatz. So let's just go through it a little bit more so we can find it's still deny. So every deny rule right here is one of those checkboxes we actually checked. So those are Microsoft recommended rules. So let's go a little bit deeper. Maybe I'll just search for it because I know that it was kind of easy last time I was trying this. But yeah, cheat engines. Okay, there are many things. But let's just see. Yeah, and here are those signers, right? So those are signers that are allowed, and that's why the whole operating system will actually be working, because most of those things are actually signed, of course. So let's just try to search for mimikatz because I'm kind of sure it's somewhere. Ah, yeah, right here. So there is again some signature that is not trusted, and here, yeah, here denied signatures, user and kernel, and yeah, that's basically it. Yes. Okay, so you can see that this is really handy actually, right? So I highly recommend to test your baselines with those two checkboxes checked. Okay, and in the beginning of this file, we have actually some configurations, and you can see that it is unsigned system integrity policy, which I explained to you just now. Then you can see that it's in audit mode, which is really important. So we are just checking for event viewer if that application would be able to run or not. We can see boot audit on failure, which I also explained before. So those are some configurations that are actually important for you. And then we have here SI policy. So this is actually the file we will be deploying, we'll be providing the group policy management console, because this XML file is actually combined into this kind of certificate, or it's, let's say, archive, or I forgot the word for it, but it's basically that this XML file, it's transformed into this specific archive. Okay, so let's take a look into our Active Directory server. I will be actually creating a policy and deploying it. So let's just use Samba share for this, admin share. So AD CLNT02. Let's go for $C. Let's go tier 2, and it was on desktop, right? Yeah, it's over here. So let's just do it like this. I will actually copy it here, and let's create our policy. When you are deploying this Windows Defender application control policy, then you have to provide that file somewhere on file share where those computers and clients can access. So we will first create that policy. So we got this computer in tier 2 computers. We got it over here. That is our client where it's located. And we will create some, let's say, variate demo ms signed, for example. And when we create it, I know already that I need some file share. So to make it simple, I will use sysvol. You can, of course, use whatever you want, but I will use in this moment sysvol share from domain controller. So I can see by timestamp that it's this policy, and I will just create here some, let's say, VDAC folder, and I will drop there that SI policy. Okay, and that's all that's needed right now. Okay, we can check, of course, that everybody has access, which of course is must have, and we can see authenticated users are allowed to list and read and execute. So that should be just enough. This is, of course, configured with this right here. Yeah, so when you are configuring delegation, this is what is actually copied, or not. It's not copied, right? But it's more of reflected from this specific folder. So when you set some permission here, then it's of course written here because it's just permission over that folder. Okay, so let's edit this this policy. Let's go to policies, administrative templates. Let's go to system and let's go to device guard. And over here, we can see deploy Windows Defender application control. Right here, we must provide that code integrity policy file path, and it expects that specific file format we got over here. So I will just copy this as path. By the way, if you want to have this option here, you must push shift and right click copy as a path. And then I will delete just this and this, and I will be using domain names. So let's do it like this, and let's just make sure it actually works, that I did not mess it up. Yeah, it's okay. Let's just apply, okay. And that's all we need to do right now from the group policy management console perspective. Let's go back to our computer and let's try to enforce it. It of course requires a restart, so we'll need to do that later. But let's just see if it applies. One good thing is that you can actually see this in event log. I'm not sure if it's actually, if you are able to see it before or after the restart, but it's logged to device guard, operational, and yeah, you can even see it before restart, right? So we can see that some policy was loaded, and it even says if a reboot is required or not. Yeah, and we can see it was successful. So we will just reboot our computer right now to see if we really were successful with this. And let's just restart it and give it a while. After we start that computer, we should be able to run almost everything that is signed by Microsoft, and we should also be able to run that secure secrets dumper tool. So that's not signed, but we created our not exclusion but allow rule for that by that folder scan. And for example, I also have installed process hacker on that computer, and we will not be able to start this process hacker, or we will be able to start it, but later on when we will check the logs, we will actually see that it would not be able to start if we would be in enforce mode, but that's really just a cosmetic thing. Okay, so let's just, oh no, that's the wrong password, I'm sorry. Okay, and let's take a look how those changes applied. Okay, I will first open event log because we are right now we need it right now, because without it we will actually not be able to make it will be no difference, because we'll be still able to run everything. As I said before, it's just in audit mode right now. You can of course enforce it, but that's not the goal over here right now. And later I will just try to run few applications. It's actually a little bit different from AppLocker because it locks just files and drivers and applications that are prevented from running. So it does not lock if it's actually able to run that specific application, which I think maybe even AppLocker does not do. Maybe I'm just mystifying you right now. So maybe it's the same. Okay, so let's just take a look over here. We can check again into the device guard if everything goes okay after start, and we can see that there is one new log, and we can see, yeah, it was successful even after the reboot. It was actually loaded. Then here is somewhere code integrity, yeah, right here, and here will be the logs about preventing some applications from running. So let's just try, for example, to run a few things. So I want to run, of course, that process hacker, because I know that this is not signed by Microsoft. Then I want to run, for example, autoruns that's signed from Microsoft. And then I want to run, for example, yeah, in System Suite, I want to run also this secure example, because as I said before, okay, let me just find it. this binary is not signed. So that's why the hash was actually there. And let's just try to run this over here in PowerShell. It will be maybe stopped by anti-malware solution, but let's just try it and we will see what happens. Okay, so it actually started. Okay, so let's take a look into our log. Okay, we have few more logs over here, kind of a lot. So let's go through it. So first we can see that process hacker was started, and it did not meet the enterprise signing level requirements. So we can see it would not be allowed to start if it would be not in allow mode. Okay, this is nothing. This is again about process hacker. So it was some part of process hacker. So it works just as expected. Again, some DLL loaded, and it will be prevented from running. And process hacker again. And process hacker again. It should be basically all that we can see here because, as I said, it logs just things that are prevented from running, and we can see this is all about that process hacker. So we can see, for example, that if I just close this, so it's a little bit more easy, then we of course will see that if I try to run again that secure example, that even though it's not signed, there is no new log. So it's actually allowed to run, and it would be allowed to run. So right now, of course, we could switch to the enforce mode, which is of course completely possible, and we can do it. But let me just change it right now. Okay, and I will just basically, oh, we need to create it of course again. Okay, so let's just try it again a little bit faster. So if you want to delete that policy from that computer, then of course you want to stop applying that group policy object. So I will just unlink this this policy, and on that computer there is actually, okay, so let's give it a while. I hate this. I hate this. Okay. Okay, we are good to go. And we can actually delete it and from that specific computer because it's actually loaded over here right now. So we will just do gp update force. It's because you want to stop that group policy from applying that specific file, but that's not enough. If you want to really remove that unsigned policy, then you have to also remove it from C drive, but I am not right now sure where it actually is. So let's maybe let's search for it on the internet, because I know that Microsoft specifically writes it what you are supposed to do. Let's do it this way. React remove policy. And if you would like to remove signed policy, then it's much harder. So you must think twice because before you actually deploy signed policy, because it's really hard from administrative perspective to remove it. Because first you must deploy a new policy that is based on that source policy and its newer version, and it must be reconfigured to be unsigned, and then you are actually able to remove that policy. So you must basically create new policy that is signed, but it allows to be unsigned policy. So it's a little bit challenging. And of course there are some scripts for it and some documentation, so it's not that hard. But I am just saying that you definitely should think twice before you actually do that. Okay, and here we can actually see where it is. So it's in Windows System 32, code integrity. Okay, Windows System 32 and code integrity. Okay, and right here, I will just delete this SI policy that is here. Now, of course, we must reboot again because we want to get rid of this configuration. And in the meantime, we can actually check because I think it's somewhere here documented how to remove signed policies. Is it here? I think it's actually here. Signed. Yes. Yes, it's that. Actually cannot find it right now, but there is definitely documentation for it. It's maybe here. Yeah, it's here. So if the policy you are trying to remove is signed VDAC policy, you must first deploy a signed replacement policy that includes option unsigned system integrity policy, and only then you will be actually able to remove it as I did. So this is something you definitely must take into account, and please review this documentation before you will actually do that. Okay, and this is our computer, it's already rebooted. So we will just quickly create a new policy and we will enforce it. And we'll see how it actually behaves. Okay, again, wrong password. I'm sorry. And let's go for it. Okay, I will just we cannot actually. Okay, let's just create a new one because we could just change in that XML file because that's what I actually tried to do before. In this XML file, we could just, of course, change it from audit to enforce mode, but then we would need to create this specific archive file, and we can, of course, do it, but I don't know that command from, I don't have it in my memory right now, so we will do it with this wizard again. It will be much easier. Okay, create a single policy again. This specific, we will just name it demo enforce. We will change it again. We will do it over here on desktop where that's enforced. And let's continue. And here let's of course boot audit on failure, and let's just uncheck this audit mode. Here we will add custom rule again, and we want of course to allow something, and we will do folder scan path. We will find that specific folder, and we will just allow it to scan it again. We will use hash and publish. Okay, it's really hard to click on it actually. And hash, and we will just create rule. Next, and it will be created in a minute. So as I said, we could of course do it manually, but I did not prepare it, so it would be much longer for me right now. So let's just create a new one, and let's just delete those things over here. And let's also delete this policy from that sysvol share, because we will use the same policy, but we will just deploy different file. So let's just give it a while again. I will just make this faster for you, so I will just skip it when it's ready. Okay, so we are ready to go. So we have here some policy on desktop, and we should see right now that it's actually in, yeah, there is not audit mode mentioned. So right now it's enforce mode. So let's just go for it one more time. So let's just add clnt02 C drive. Let's go for users T0 desktop tier 2, excuse me, and let's use this this policy. I will copy it here. Again, I will just I don't even need to do that because it should be still the same file in the same policy. Okay, so let's just do it like that, and let's just enable that specific policy because we don't even need to do anything. It's still the same name of that file. So let's go back here. Let's do gp update force. Okay, so I would need to write that properly. Force let's one more time take a look into event log because I want to see that it actually applied. Okay. And let's just wait till this loads. Come on. Okay. Thank you. Let's go to Windows and let's search for code integrity, which is here. Oh, not code integrity. We will actually be looking for device guard because we want to know if the policy is loaded, and it was successfully processed. And as just as before, it's still the same. We need to restart that computer, of course. So let's do that. And after restart, it should be doing something. So let's just wait for that. Okay. Yes, of course. Resizing, as always. Console resizing is always the thing on Hyper-V, so that's what we love, of course. Okay, let's go for this. And let's just try to run a few applications if it actually works as expected and as configured. So let's first start with something that we know should be able to run. So let's, for example, start autoruns and AD Explorer, for example. Those are two applications that are definitely allowed. Nice, they are. And now let's try even that secure application because that's our specific hash allow rule. Okay, let's run it again through PowerShell. Oh, it's okay, so it was actually allowed to run. And now let's try to run that process hacker. Ah, yeah, and it was actually blocked by Windows Defender application control. So as you can see, in this kind of perspective, it's really similar to AppLocker because we have that wizard, but it's still more complicated because the background of Windows Defender application control is much deeper than AppLocker. AppLocker is just a service that you are able to stop, of course, as administrator, and it's nothing else. There is no kernel included in that, no integrity, etc., etc. In Windows Defender application control, it's much different because we have kernel mode, user mode. We can say which drivers are allowed to be loaded, which applications are allowed to be loaded, etc., etc. And we can even check for integrity of that specific policy file. We can prevent that device from booting. We can prevent administrators from even bypassing and modifying those policies. So it's much more complex, but in demo environment it's a simple task. Yeah, so that's why it was actually that fast and easy, because it's not hard to use that wizard to create some basic rules for Microsoft Sign applications and drivers. So it's kind of easy and quick. But if you are in production environment, then you will be probably having much more drivers and applications that of course could be prevented from running right during the startup of that computer. So always use audit mode. Of course, use AppLocker or the Windows Defender application control. Use some kind of application allow listing and always start with audit mode. So that's of course something you should do. So I hope you like this demonstration, and let's get back to our presentation. So this is the end of this chapter. I hope you enjoyed this session, and let's see you in the next one. So let's take a look, for example, in that AppLocker feature. So AppLocker, as I said, is for allow listing or block listing, but of course use it in allow listing mode. It can allow list executable files, scripts, Windows installer files, DLL files, and package apps and package app installers. Those package apps and package app installers, this is actually that bloatware we were talking about in the chapter about Enterprise LTSC version of Windows 10. That is actually missing those kind of this kind of bloatware. AppLocker has one huge pitfall, and that is actually AppLocker runs in user mode space. So it runs basically as, or not specifically in user mode space, but it actually runs as a service in that operating systems, which means that if you are an administrator on that computer, you can just turn off this feature. So that's a little bit inconvenient because you must first get rid of administrators' privileges for users, which is anyway something you should be doing before application allow listing, because if we would be speaking about some maturity level in cybersecurity, then definitely one of the first things you must do is remove administrators' privileges from users, and then of course rotate passwords for local administrator accounts. But anyway, it's of course it's worth a mention that that service can be stopped by administrators. So if there is some privilege escalation path or some, let's say, vulnerability in that service or in that application, then it's really easy to bypass this specific application allow listing. You can configure it through local group policy editor or through group policy management console in Active Directory. It's really easy to navigate through, so it's kind of simple. You can even see, as you can see in the picture, you can even create some default rules. Do not expect anything from those default rules. They are definitely not secure. Like, it's not something you want to configure and just let's say you are finished with that project. No, it does not work that way. Those default rules are definitely they have many holes in them. For example, one of them is that Microsoft Teams is installed, that software is installed in app data of that specific user. And for example, as you can see in those rules, there is no allow rule to access those app data folder, that app data folder. So that's, for example, one thing that will stop working, and that's just one example. Then there is, for example, second case where everyone is allowed to run everything from Windows folder with those default rules. But in Windows folder, there is a Windows 10 folder. And in Windows 10 folder, the ACL, access control list, actually allow users to drop any kind of executable file they want. So they would be able to run anything they want, basically. So those default rules are not something you want to be using. So definitely find something else or develop some of your own. One benefit is that you can audit or enforce this application allow listing, which means that basically when you create some set of rules, then you can just turn it in audit mode, which means that in event log you will see if that application or script would be allowed to run or if it would be not allowed to run. This is something I highly recommend because you can break with application allow listing your computer. It will not even be able to boot up. So definitely test it with this audit only mode, and the planning phase should be really, really lengthy actually. It's only user mode oriented, so that's of course, as I already said, that relates to that specific service that actually is running there, and those rules are defined per user or per group. So basically you specify some user or some group, and you can granularly say for example that administrator or somebody is able to run this and somebody else is able to run this application. So this can be of course convenient. In the slide you can see that there is a URL to github.com Microsoft Aaron Locker or Aaron Locker. This is a place where you can find some PowerShell scripts and some documentations that will make your life with implementing AppLocker much easier. I highly recommend it. It will help you to successfully implement AppLocker, and it will help you to protect your environment correctly. And basically, as I was talking about those security holes in those default rules, so those scripts are also something that are actually searching for. So they are searching for those kind of misconfigurations or holes in those rule sets, and they will help you to make it better and make it secured. So let's take a look into our demo and let's play a little bit with AppLocker. Let's take a look into our demo environment and let's demonstrate how to use AppLocker and how to create some basic rules. And also we'll demonstrate how to use Aaron Locker project that focuses on creating AppLocker rules in a little bit more complex way. So we will be creating those AppLocker rules through our domain, so through Group Policy Management Console. So we want to enforce it that way. And we'll be creating those rules for our device ADCLNT02. We have seen this device before in other demos. Right now we are on our server where we have this RSAT console available. So we are on AD Survey 01. And I am of course domain administrator, so I'm able to create that policy. I will be creating a policy based on some binaries. So I have here, for example, sysinternal suite from Microsoft. Those are binaries signed by Microsoft specifically, as you can see here in digital signature in properties. And this is what I'm going to use for that AppLocker rule. So the goal will be that I am not able to run process hacker because process hacker binary is of course signed by somebody by somebody else. So this is the goal over here. So let's create that policy. So let's name it, for example, AppLocker policy. And let's get into it. Okay, edit, policies, Windows settings, security settings. And now we are looking for application control policies, and then we are looking for AppLocker. Be careful, do not use software restriction policies. Those are old policies, and nowadays we use, of course, AppLocker. So always use application control policies. As you can see, we have here a list of some rules. So executable rules, Windows installer rules, script rules, and packaged app rules. If you remember from my presentation, then we are missing here DLL rules because AppLocker can also create rules for libraries. To be able to see libraries, we need to go Properties, Advanced, and enable DLL rule collection. As you can see, here is a warning because Microsoft knows that it's very easy to break your computer with those rules. So that's why they are hidden. That's why they are actually not listed by default, because Microsoft want to kind of warn us. So we bear that in mind. Okay, and if we click OK, we can see that script rules are here. But we want to focus only on executable rules right now. So let's create some really simple rule. So we have here some wizard. It's really simple. We select if you want to allow or deny. So we will set, of course, allow for everyone, because as we have discussed during my presentation, we want to use application allow listing for allowing applications that we trust. So everything else gets blocked and denied if it's unknown, because for denying we have antivirus and anti-malware solutions that are of course using different approach, and then they are denying the things that are bad and that are known. So that's why application allow listing has different approach, and we want to allow only things that we trust in. So that's why we will set allow here. We will set condition based on publisher. And here we need to pick some reference file. As that reference file, I will pick that AD Explorer from sysinternal suite. And here you have some attributes that you can use, some values. And you have here some slider, and you can slide this slider where you want, or based on that what you want to use. So I want to use just publisher, so I would slide it to this level. You can even custom those values, but that's not something I would like to do right now. So let's use just a publisher. That's the most easiest way right now. So everything from Microsoft will be allowed to run for everyone. Now we can add some exceptions. That's something you are going to see a lot if you are creating some more complex policies, but right now let's just skip this part. And next, and let's create that rule. Right now it's asking me if I want to create default rules, which I do not want to create right now. So let's click no. And we have just one rule over here. For that rule to be effective, we need to click properties on AppLocker, and we need to configure those executable rules, and we want to audit them. As I said during my presentation, you always want to start with audit unless you are very sure about what you are doing, but you always want to create those rules and set it to audit because you want to observe your environment, you want to collect some data, and you want to see what those rules are actually blocking in your production environment before you actually enforce them. Because there always can be some misconfiguration or something that you missed during that configuration. So let's do it this way. Okay, AppLocker is configured. Another thing you must do is that you need to enable application identity service, because AppLocker is enforced and those rules are enforced by application identity service. If this service is not running, then those rules are not effective. As you can see, that service is not running by default and it's set to manual trigger start. We need to set this to automatic. It's something that we are not able to do through graphical user interface because that service is protected. So even administrator is not able to turn off this service very easily. So of course, administrator always can find a way to bypass this service, but it's not that simple as it used to be. So we need to configure this service through our group policy management console, so through domain. So we will go to security settings, system services, and here we will find application identity service and set it to automatic. And that's basically all we need to do. So our policy is created and our policy is applied to our computer that is in computer's organizational unit. So let's